sort of stays kind of reddish, pinkish, orangish, and it's one of the problems that we face at pretty much any star party. Or literally, this is kind of a dark sky preserve. You look to the south here, there's absolutely nobody living there, and your nearest neighbor is miles and miles and miles and miles and miles away. The only neighbors we have problems with are all those guys living in Bend.
Oh, coasting to a stop, more or less in the right spot.
I'm pretty sure you're going to see Jupiter the way this thing's aimed.
Oh, no. It's okay. It's okay, man. This is kind of like a finder scope. That's how I find it. It's a miniature telescope.
About the size of you.
What's called a Kuiper belt object.
Okay.
Because Kuiper was the guy who discovered that there were going to be all these objects out there. So of course people who are traditionalists like to say, well, Pluto's a planet, so this one has to be a planet, which is a perfectly valid way of thinking.
Welcome to Mount Wilson. My name is Omar Garza, and I'm a docent here at Mount Wilson Observatory. Mount Wilson Observatory is the birthplace of the science of cosmology. That's the only science that was really developed in the United States. But what I'm here for is to tell you, you don't have to be at a Mount Wilson or a major observatory to do astronomy. You can do astronomy from your backyard, or with your local astronomical society, your school, or whatever. Just go out to your backyard and go out and look.
If you're going to hold a star party, if you don't have any resources, it's just not going to work, because if you don't know the sky at all, you've never seen the sky, it's a steep learning curve to start with. And it's like in the ballpark of a year probably of observing before you start to get the hang of what's in the sky and what to see, what it looks like, and what it really means. Both of them last night I was talking about the moment of discovery, this concept of the moment of discovery, how that's so powerful, not only science, but in the arts also, and humanities, and anything academic. But this moment of discovery idea, or the happening, the moment of discovery, and that may be the crux of what makes a Star Party successful. Is when the viewer goes, "Oh wow, that's really the." But then Alan Chambers, then the day after, saying that it was the funniest thing he ever heard. That he was having such a great time, but while he was working in the dome, all he heard is all these squeals of delight and giggles of delight, and as they were finding things, they had books that they were finding stuff with, but it was this moment of discovery at kind of the epitome of the moment of discovery for them. So that was really what was a very, very powerful, positive experience for them. So. The two key ingredients, equipment and sight. That's what we have to have to begin with. Okay. You have to have telescopes. They don't have to necessarily be big telescopes, although it's more wowy if they are. But it's more critical that they're telescopes that are easy for the kids to work with, which basically, preferably Dobsonian mounts, something that they can actually use hands-on. So either the school has to have the equipment, or parents have to have the equipment, or probably better yet, there's the local astronomical society that can provide the equipment along with the expertise to use it. So that's the first part of the equation. The second part, equally important, is sight. There has to be a suitable dark sky, low horizon sight to look at the objects. And there are a few other minor details, of course, like sprinklers and parking and safe footing at nighttime, things like that, and of course creature comforts too. So it's critical to pre-scout the site. You want to actually go out there at night, look at it under different lighting conditions, look at it under the conditions that the star party will be held, and spend some time actually out there looking at the sky. What's it really like? Can we see in all directions? What directions can't we see? Does it really matter? You don't have to see in all directions, but you generally want to see south. Generally want to see overhead pretty well. North is really not that critical. So those are the two most critical things. If you don't have equipment, if you don't have a site, you don't have a star party. Okay. So then, in terms of expectations for the leaders of the star party, the teachers, preparation, previewing expectations, it's probably pretty critical that they get a view beforehand through these instruments of what the typical objects will be that they'll be looking at, so that they know beforehand what to expect, what the views are like, what the basic techniques are for viewing through a telescope, which is foreign to everybody the first couple of times. You know, how close do I get to the eyepiece? Which way do I turn my head? Do I keep my glasses on or not? So these are all the questions students will be asking, and so it's very critical that the teachers have this preparation and preview beforehand. Determining the target list, that's an experience aspect, and there again it's critically important that you get somebody involved that has the experience with the sky. The books and literature around and internet stuff is all great for furnishing catalogs, but it really doesn't tell you which are the most suitable objects for looking at with a given group of audience, of students. So it's pretty critical to determine what objects are selected for viewing. Often the moon is a good prime object. If there's planets available, that's always good. The moon, speaking of which, you want to check on the moon phase. You don't want to hold your star party at full moon. That creates a big problem. So ideally, like between new moon and first quarter moon. So you have the moon to look at, and yet it's going to be not drowning out everything else. So there again, experience is a critical factor, picking the target list. As far as the students, there's a need for pre-knowledge. And if they get a little bit of background in even a 45 or 60 minute session before they get to the star party, probably will add a lot to what they can get out of the star party. The critical things would be the distance concept, do a scale model of the solar system, do a scale model out in the galaxy, and familiarize them at least with the hierarchy, the three zones of space, as I call it, the solar system, the galaxy, and beyond. so that they have a little bit of a handle on really what they're looking at. And then also familiarizing them a little bit with the technology. You know, what does a telescope really do? How does it gather and focus light? Why are the objects upside down? If there's a digital camera involved, what does that do? How is that advantageous to what they can see? So a preview of the technology, a little bit of technology pre-knowledge goes a long way, along with the background knowledge. As they're observing, I think it's pretty critical that they have actual recording to do. Not only because it's an important skill as a scientist to do recording and observational notes, but it'll also make much better observers of them. They'll be much more critical observers if they need to do a drawing or do a written description or do a chart or a diagram of what they're seeing. It will really make them look a lot more carefully rather than just looking and saying, okay, here it is. They'll have to do a little more thorough examination. And then probably last but not least, follow-up the day after, question and answer session, discussion, reflection. You know, what did we see? What was interesting? Why was it interesting? What didn't we see? What do we want to see next time? What problems do we have? What good things do we have? What were the oh wows? What were the moments of discovery? Kind of close the circle. They really like the planets. There's no doubt about that. They're very, very fascinated seeing the planets. They're amazed at the detail they can see on the planets and the moons of the planets in some cases. There's probably a little less enthusiasm about some of the deep sky objects and nebulas and galaxies, just in that they probably don't always grasp what they're seeing. And that comes back to this element of prior knowledge that I was discussing a little bit. I mean, the ones that have done some studying about what these things are, they're very excited to see these objects, but typically they're just fuzzballs. I guess maybe that's another point, is that at the typical star party, the typical telescope, a lot of these objects are just gray smudges. And so unless you really start thinking about what you're seeing and doing a little more critical viewing, in that sense they may not be that exciting as compared to, say, the planets and the moon, which are very bright in the telescopes. So even though in a sense there's a lot more significance about these deep sky objects, unless there's some background, it doesn't have really the immediate impact. Really concentrate on just a couple of objects. The goal isn't to see how many objects you can see. The goal is to get as many wows and these moments of discovery from the viewers that you can. And it takes time for people to really spend a few minutes at the telescopes and go through a line. So typically, even here at Pine Mountain, we're lucky if people see 2 to 3 objects through the big telescopes when they're here for a couple hours. So that shouldn't, you shouldn't think of that as being disappointing. If people get a good view of, let's say, the moon and a planet and a star cluster, that's pretty neat if they really get those discovery moments. When the parents do accompany their youngsters and actually are interested in viewing and talking with their youngsters about what is being viewed, it seems to boost the whole experience for everybody. So yeah, in that sense, coming back to that last question, that the more successful star parties are when more of the parents participate, without a doubt. And I guess as a counter to that, we have had some problems where some of the parents think that we're babysitting and will drop their kids off, and that doesn't work usually. Kids run around and just don't know what to do and are unsupervised, and so that I would caution strongly against doing that. Normally, what I try to do when I'm the arranger with a school, I will say that you need to notify the parents that there needs to be an adult with accompanying their child all the time, for safety and liability reasons as well as academic reasons. Judicious use of subtle lighting sometimes helps, like small red LEDs to mark the base of the telescope so people don't trip over them, or even at the eyepiece of the telescope to guide somebody to the eyepiece. The new laser pointers are very nice to point out things in the sky, although again with an element of caution with their use, but certainly a helpful tool to point out. Having star charts is another nice thing to have, although the problem we run into is that a lot of people don't bring flashlights or bring a big flashlight, which is not good, which is even worse than having no light. So star charts can help, but are not necessarily a per se for the Star Party, particularly if somebody's available to point out the sky. Oh, that's another thing in terms of strategy, that if you want one person for each telescope plus a couple of rovers. And if you have a couple of rovers, and that's what we try to do up here too at the observatory, then the rovers can be pointing out objects with the laser pens in the sky and just talking to people about questions and kind of picking up all the loose ends that way. The best is if something unusual in the sky happens, like an aurora or a couple of bright meteors or something that's really jazzy like that. And of course, if the objects to see are well placed and readily visible, and they're interesting objects like Saturn and things like that. In terms of worst school star parties, I really can't think of any major catastrophes per se. We have been hit by sprinklers a few times, which is why I mentioned that initially. Other than that, and perhaps a couple times when we were forced by just the district schedule to use a full moon night and couldn't see that much. That's probably about all I can readily recall. It really hasn't worked that well. University of Oregon's Pine Mountain Observatory, located in Central Oregon at the 6,500-foot level. And it's a research facility originally. It is now a public education facility with a number of telescopes and digital cameras that can be used for the general public and students and teachers to do observing and collect and acquire data. Because of the digital electronic technology, another way of doing a star party would be remote observing. That is, the students could image, that is, take pictures electronically through an observatory's instruments and have them then to view on their computers, which generally speaking yield a lot more detail, a lot more interesting images, and of course they can be saved and analyzed and looked at later on. The students get the idea of the possession of their own images, as they can take their own images. So there are many, many advantages to that, and we're a facility that could certainly offer this kind of an opportunity to do a remote star party.
I really enjoy doing star parties for kids. It's interesting at the age of 5th and 6th grade, the students have this total absolute fascination with space. And so it turns out to be a really great thing to do first thing in the year. And I like to start off with a bang. And so I spend about 3 weeks. First I tell the kids that they're going to culminate in 3 weeks, they're going to actually host a star party for several communities. They're going to teach another school all of the things that they know about space that they've learned, and they're going to do it within the span of 3 to 4 weeks. They're going to have guest speakers and things like that, and that gets them, oh my gosh, it gets the level of concern up, but yet excitement, and so they're really excited. I spent about 3 weeks building background knowledge and try to fit the Oregon State standards in a fun way using hands-on activities, etc. I teach Earth's place in the solar system, phases of the moon, hierarchy of the universe, light year, large distances, and use distance models of the solar system, nearest star, galaxies, etc. Objects in the universe, and also teach, of course, about the constellations. And those are the basics things that I would go over with the kids ahead of time. We'd go outside and we would do different hands-on activities and modeling activities. The resources that I would use are textbooks, nonfiction trade books, lots of multicultural myths and legends to kind of bring in the language arts pieces. I use local experts. I use the Umpqua astronomers a lot, Paul Morgan of the Umpqua astronomers. I would use Rick Kang out of U of O. Lots of films, lots of videos, and internet web quests, things like that to help build this background knowledge. Some of the projects and products that come out of this are, I have the kids for language arts write an original myth or legend based on a constellation of their choice, or some other space object that they'd like to imagine and create a myth for. We also have written letters to the school board to earn try to have the school board budget for telescopes and things, and we have several telescopes now at our school based on the letters that the students have written to the school board. I have the students become an expert in an area, and this is helping them to prepare to become the person that's going to teach another school. And so some of the things they might become experts in is they might become experts in phases of the moon. So they might do moon on a stick and have the styrofoam balls and different activities that go along with learning the phases of the moon. I would have students learn about the constellations and then do make constellation viewers using pins and what do you call them? Film canisters. And then they would have the young students make the same things. Then I would have storytellers, and they would learn how to tell myths and legends in a very exciting way, and to teach kindergartners, first, second, third graders, those kinds of things. So those are some of the expert activities that they might get into. I would have guest speakers. I usually have Rick Kang come from U of O, and he teaches several lessons over the span of maybe a week to the students. So we have another perspective and someone who is out there in the world, and he brings in his cameras and different activities and teaches them about photons and light and things that I don't have access to because I don't have that kind of equipment. So that's a lot of fun. The kids really like him. And then we plan the Star Party. And generally we plan a Star Party that one night we teach the kids how to be star experts using experts from the U of O and from the Umpqua astronomers, and we teach them how to use telescopes, etc. And then the next night they would host a star party for the school that they have taught their lessons to. I always provide red cellophane for the flashlights, and I would send home notices the week before so that the people would know that they would need to bring flashlights and warm clothes and air mattresses or that kind of thing, whatever they might need. And one really important thing to tell parents is that I want this to be a family event. This is not a drop your kid off and you go to the bar. This is bring your family, because I've had that happen. And so that's one thing that I want teachers to be aware of, is that that parents need to be there with their children, and so that you can be running a telescope and teaching and not have to be supervising and being on duty. I always do have some extra people there on duty just in case, but I find that to be much easier. Then you can pay attention to your telescope and to your people and not have to worry about all these kids in the corner, what are they doing? And so I make that very clear. This is not babysitting. This is an activity that we're volunteering for, and so you need to be in charge of your own student. I would have experts lined up from weeks to months ahead of time from the local astronomy clubs, and so then I usually have 4 or 5 different telescopes up at least, and we've had up to 100 to 150 people at the star parties. I put up signs publicizing the event at different places. I use this also as a fundraising opportunity, because the people love having hot chocolate available, muffins, cupcakes, and it gives your kids a chance to maybe earn some more astronomy equipment or science equipment for the school. I have a parking attendant so that when the cars come, they can get their lights turned down to parking lights, and keeping people moving slowly so that they don't rush through and run over somebody who's in the dark. And I always find out different places to go. I've gone to parks, and I've asked if we can have the lights turned off at the park. We've done it outside the school, and I just make sure that the lights are turned off. And so you have to kind of research a good site, and you also research a good time to do it. I find a good time to do it is when there's a nice crescent moon, because then crescent or quarter moon, so that you can do some moon viewing. The kids love, and the parents love to see the craters of the moon and all that kind of thing. I also make sure that the principal or somebody is there to also supervise. And another fun thing is to get the newspaper involved. Get somebody to come from the newspaper to kind of do an article on you. The Star Party itself, we have activities for people that don't have telescopes, and so I like to have family activities. So I have a treasure hunt for different objects in the sky, and they earn points based on the different objects that they can find with their family. And that way they can use naked eye and they can use binoculars and not have to just be relying on telescopes. And they really seem to enjoy the treasure hunt. And I've watched families come and they bring their air mattresses, and all of them will lay on the air mattress, look at their flashlights, and they're looking for the different objects using the star maps that I would provide for them. And it's wonderful to see these families together with their hot chocolate and being together and doing activities like this, and it's really cool. Usually I'll have candy or some treat, so if they fill out their treasure hunt, they can go get a piece of candy. But that gets the kids excited. He usually brings, I'm embarrassed, I forgot the name of the camera that he brings.
CCD?
Thank you. The CCD camera. He brings his big wooden one that the kids learn how to shoot and edit, and he brings his laptop, and the kids are learning how to actually push the right buttons and change the values of the different items on the laptop. I only teach 5th and 6th grade. I don't have all of the lingo. And the kids love it. And he sets up his materials there. And then several people have the go-to scopes, and so they will come from Umpqua astronomers and they'll set up their go-to scopes. It comes to find out one of the custodians at our building loves astronomy, and so she just loves to bring her telescopes. And so you find out, people come out of the woodwork. The people who are astronomers in their backyards don't realize that it's something that the kids would be involved in, and they'll start bringing their scopes. I try to plan my star parties around when he's there, because then I have that expert person there, and he is actively, he sets up his table and he sets up everything, and he is just one of the telescopes, one of the people, and that the people can go to, and then they can sit in the chair and he can point it to whatever they want, and then they can learn to take a picture and they can learn to edit and things like that. So he's actively right there.
Okay.
He's just one of the members, but I do try to have him there at the time, because then it helps. Sometimes we have been rained out, and if something happens and we're rained out, I just move into a gym, and he can do a activity with his laptop and show objects in space and do some of the same kinds of things you would do. And he has kept the audience going for an hour to an hour and a half. In fact, I have found that if you do enough background knowledge, you get into redshift, you get into all sorts of things with 4th, 5th, and 6th graders that blow away the adults. And so once we had Rick come, and we got rained out, and Rick came, and those kids were asking questions for an hour and a half, 2 hours, and the parents behind them were looking at them like, what? You know that? And you know, and the parents didn't know what was going on. The kids were just shooting the questions at Rick. And it was so exciting, because if they hadn't had that background knowledge, they would have not understood either. But they were so excited to have this expert and ask these questions about Saturn or Venus or galaxies or, you know, colliding stars or something, and it's just real exciting to see that. They do, but since they haven't had the background knowledge, they feel kind of shy. They're kind of shy about it, because a lot of them have not had. They're kind of at a lower developmental area than their kids are at that point. And so they're going to ask the simple questions, and then their kids can answer it. So it is kind of cute, because they'll go, Mom, we're in a crescent moon right now, you know, those kinds of things. And it's fun to watch, because the kids can teach the parents. Then they get more interested. And we have found that the star parties build every year. They ask, you know, are you going to have your star party? And they can't wait to come. We have a lot of the same people come, and they bring grandmas and grandpas, and it's a lot of fun. Well, I feel that when we have the kids do kind of the service part of it, and that's learning the activities, teaching other schools, and then going to those schools and actually hosting star parties, it raises their level of, wow, I can do something for somebody else. And especially at this age, they love to help. And so I found that the kids that did come and host, they took over. You don't need to prompt them. They know what's going on. And then I find that carries over through it for the rest of the year, because then that was hard. It was a hard thing for them to teach another class. It was a hard thing for them to be in charge of a telescope. And then later on, they have more confidence. And they've done something hard, and they've done something that pushed the envelope a bit. And it really does push the envelope a bit, especially when they have to become experts and spend an hour teaching a class that they don't know about space. And they think they can't do it, and they're so nervous, but then when they're done, they want to do it again. And so it does carry over, in that they can't wait to find something else to teach to another class, or something else to take to that level. And it really does, you get wonderful writing samples and things out of these kinds of experiences, because it's so narrative. They can take it from their lives, and this is how I felt, and This is what I learned, and you get pages and pages from these kids. Kids will start asking, where can I buy a telescope? And we'll teach them the kinds of telescopes that they should buy. You know, not the Walmart scopes, but I hand out handouts of, this is the different companies, and this is, for this amount of money, this is the kind of scope you could get, and the kind of scope that the kids can handle. And then they learn how to handle the Dobsonians, etc., that I have, and then they can't wait to go out and buy some. Almost every year I have 3 or 4 kids at least that ask, and their parents buy them for Christmas. The nice scopes for them, and then they're hooked for life. It's really fun.
The first thing we try to do is pick a date that's appropriate for the moon. With a public star party, here, at least here in Roseburg, we're trying to work with people that are going to be more excited about some of the brighter things they can see in the sky. And so one of the best things I think we can show people they can relate to very easily, because they can see it in the sky, they understand it, is the moon. So we try to make sure that we have somewhere near first quarter moon. It can be a few days either way, it doesn't matter. We don't want a full moon, or we don't want a new moon. And typically it's a Friday or Saturday night where we can get people out. So we want to find out when the right moon date is, and then we try to do it when the weather hopefully is good, although lately we haven't been too fortunate at that. But the idea is to try and make sure we have the right conditions. You know, if we have the moon that's right, then we can have other things. If we have bright planets, it's a real bonus. This year we haven't had much luck with that. But many times we can either have Jupiter or Mars or something like that, and that helps a lot too. Because people really want to see those kind of things. We've tried different things over the years. Sometimes we used to have where we had different objects with each telescope. One person would be on, say, M57, the ring. Someone else would be on M11 and so forth, and we'd go around and have people kind of make a loop and see different types of things and work that through. That was kind of fun, but it took an awful lot of preparation and a lot of work with the volunteers that want to come and do that. So we haven't done that very often. Most of the time, we just try to show several telescopes showing some of the brighter things. I recommend to everyone when they're just learning astronomy to start with binoculars, because that way they can start to learn the sky, they can get an appreciation of what is involved in astronomy, and see if they really want to pursue it as a lifelong hobby. And if they do, they can then go to smaller and maybe even larger telescopes. But this is a great place to start. They can learn so much and see so much just with a pair of binoculars. They don't even have to be this big or this fancy. I mean, you can start with something that's pretty small. Even some small binoculars like these will really help when you're trying to learn the sky, know the different constellations, and watch what's going on. You can see so much just with binoculars that after you've spent a year or so practicing and learning, you'll really know your way around and you're ready to move to the next step. This little telescope here I'm holding in my lap it's a refractor, and it has, you can see here, it has a lens in this end, so it has a piece of glass or pieces of glass that brings the light down to a focus at where you would place an eyepiece right in here, or an imager. That's one type of telescope. This telescope here has a large mirror. It's an 11-inch mirror in the back of this telescope, and then it has a corrector plate, another lens in the front, which makes the telescope fairly compact. So it has a fairly long focal length, and this one has a very short focal length. This one then makes the images are pretty small. You have to use fairly high magnification to see a lot of detail. This one, on the other hand, tends to be where you have to try and use eyepieces to show your wider views. They all have different uses and purposes, and they're all good to take to star parties. The most typical telescope you'll run into at a star party, and that's a reflecting telescope. And a reflecting telescope has a mirror. I don't know if you can see that or not in there. But if you look down this big tube here, all the way to the bottom is an 8-inch mirror. And this mirror, of course, takes and reflects the light, brings it up to focus with an eyepiece up here with a little diagonal mirror, which brings it on all the way out. Very simple technique. Just works really easy. But the mount is what's special about this telescope. Notice that I can swing it easily in what's called azimuth, which is the direction around the horizon, or altitude, which means up and down, very, very easily. This is another tool that's very handy to have at star parties, is to show the public that they don't need just a telescope. They can use binoculars. And of course, if you have a nice tripod like this, then the binoculars stay in place, so you can find an object, say like something in the Milky Way where there's lots of stars, put it on it and bring people up and let them take a look, and they'll really be impressed. So binoculars are great to take to star parties too, because people then can see wide fields and they can really see lots of stars, and it's very, very fun for them. You can use everything down from, this is a 70 millimeter ETX, and using one of these little webcams, because they have such a high magnification rate due to the small chip, you can actually get some very nice images of the moon or planets, even with a small telescope like this. And of course it's helpful if you have something like this that's motorized. And I can power this thing, once again, off of my battery here and run it through the star party. And if it's motorized, it's going to help it track better with the camera and keep things aligned so you can show people as you go along. So it doesn't really matter what size. This size, small size, is okay, because you can do lots of things with it. Bigger telescopes are obviously more exciting. People like to see big scopes, but a lot of times they're difficult to bring and set up, and most people have a hard time doing that. So what we see most of star parties are the 8 to 10 inch range telescopes, and they work just great. People can see a lot in an 8-inch telescope, and we have a lot of people that bring their Dobsonians. A few people bring their Schmidt-Cassegrains, and so there's a good mix of different kinds of telescopes. One of the nice things for school kids with a telescope this size and its focal length, typically, even if you're pointing way up in the sky, the eyepiece is still down very low, which is very convenient for either small individuals or kids. All you need at the very most is a small box. Whereas if you've got a great, big, huge telescope and the eyepiece is way up here, it's going to make it much more difficult for small kids, particularly school kids, to actually see things in the telescope. And of course, when the telescope is pointing down closer to the horizon, it's very, very easy for anyone to walk up and take a look in the telescope. And someone can learn how to operate one of these telescopes in about 3 or 4 minutes. So handy, quick and simple, and great views of the sky. I mean, an 8-inch telescope will show you so many different things in the sky that you can just be busy with it for many, many years. And of course, there's enough things to show people at star parties that you'll have plenty to show all night. Guys have enough light gathering. Remember, they have an 8-inch mirror that you can see star clusters, you can see nebula, you can see galaxies, and you can see double stars and variable stars. Lots of things you can look at with these scopes. So they're widely versatile, not only just the planets, the moon, and of course with a special filter, the sun, they also will permit you to see an assortment of things in the sky. So very versatile. They allow you to show your intended audience almost anything that's up that night. Well, I found some very useful things for demonstrating bright objects at star parties. Things like the moon. If you're there in the afternoon, you can look at the sun, bright planets, double stars, things like that. What I have here is a real simple, called an electronic eyepiece. It's an 1.25 inch barrel, and then it has a little chip, and on the very top is a battery, 9-volt battery. And this very simple device. Has an on-off switch, and then it helps you regulate the gain. And if you looked in here, you'd see a little chip. Very simple web camera, if you will, and a chip. So it's sending out a stream of images, and those images then, let's see, can be sent to a television, or you can also send it to a computer, whichever you want. So if you have some images that you are particularly interested in doing some enhancing or some other work later for maybe a group presentation, you can show it live, or you can then record it on your computer and do both.
Oh yeah. There it is.
Oh, it's made out of wood. I made it. It's based on the Krieg and Berry design, and it's built for about a 22-inch mirror, but there's only a 17, about half-inch mirror sitting in it. Weighs 160 pounds, 9 foot tall, and rather difficult to load into the pickup truck. Generally, if you're at a start party, there's only a few, really bright things to look at. Once those are all done, everybody wants to look at something else, and so you go for one of these types of scopes, and then you go for the deep sky, really, really deep sky objects, showing people quasars that are 1 billion light years out, or a galaxy that's 1.5 billion light years out. So that's kind of the thrill of it. It's also kind of nice in really dark skies, even with the bright objects, because you're actually able to see quite a bit more detail than you are with a smaller telescope.
A lot of the schools are really interested in having star parties. You're interested in having people come out and experience some things, and the specialists certainly, when they visit your school, are able to come out and share some of these things. But a lot of times people have anxieties about things. They really don't know what to expect, and so we thought it would be a really good idea to invite some friends to come up with some telescopes and to talk about star parties and what it is that you could do and some of the potential, and give you a chance to look at some really cool things. When we went up to the other observatory, you got to look at two things. Through an old telescope, which it was kind of a reverential experience to look through the telescope, but you're going to get far superior views through having the smallest of these scopes. But there's a few things about having a star party that are fairly important. One of the things that a lot of people aren't really aware of is that there's an etiquette when you attend star parties. And there's several things that are really, really important. And one is it's when you move around after dark, and usually you don't want to have lights on. You're kind of defeating the purpose if you have lights on. So all the lights are out, you can't see, you've got these legs sticking out, and so you need to be careful when you move around at night, because people, if you turn on a white light, they're going to get kind of upset with you. And if you go take flash photography at night, they're going to get kind of upset with you. Because we have this thing called dark adaptation in our eyes, and the longer you're without the white light, the better your night vision becomes. And once you expose a little bit of white light to your eye, what do you think? 20 minutes, 25 minutes to get even partial dark adaptation back?
45 for...
And, yeah. And it takes a long time to get that dark adaptation back. Those of us that have been to a lot of star parties out in very dark locations, you notice that in the middle of the night, 2 o'clock, 3 o'clock at night, you've been without any kind of light for a long time, you start to get to walking around, even though there's rocks on the ground, without turning on your flashlights. And you're able to get around without worrying about it, because there's enough light from the stars, it just seems like you're able to cope. When you do use a flashlight, use one of these. Because the red light doesn't do anything bad to your night vision. You're able to maintain your night vision by using the red. Another thing that's fairly important is when you're looking through telescopes, and in hearing some of the comments that some of them were making as you were looking, there's some courtesy to be had there. A lot of these instruments are fairly expensive, and you want to be careful. You don't want to push against people. And kids like to really, as you know, kids like to really cluster around and push against each other. And you know, sometimes it's really hard to get them to not do that. And it's really important that they learn to not cluster. They'll get their chance. They'll get their turn. And then the other thing that the kids do, and adults like to do this too, they like to come up and they rest on the telescope while they're looking. They grab the eyepiece while they're looking. And if you ask somebody, well, how come you grab the eyepiece? Oh, I'm trying to steady the telescope. Well, what they're really trying to do is steady themselves, because the telescope is attached to the ground, which is the Earth, and I don't think that there's anything with a greater steadying influence on the telescope than the Earth. And so if you touch it, all you're going to do is transfer the vibrations from you down through your hand into the telescope, and you're actually going to cause the view through the eyepiece to not be as good as it would be if you just kept your hands off the eyepiece. So that's kind of, there's some kind of basic courtesies and basic etiquette at star parties, and once everyone understands that, it makes life a lot easier. Red flashlights, they're not that expensive. This is a more expensive one that I bought because it has a variable brightness, which is nice. And if you can't afford these to get, you know, ones that are dedicated red ones, it's really easy. Just buy some white ones, get some red cellophane, take a rubber band and rubber band it on the outside. If you can't get red cellophane, red balloons work really well too. And stick them on there and stretch them really tight, and you'll get plenty of light. And you might think, oh, there's not enough light that comes out. Well, it turns out that there really is. If your eyes are nice and dark adapted, you don't need a whole lot of light. The best instrument you have for looking at the sky, what do you think the best instrument is?
Your eyes. Your eyes.
Yeah, your own eyes. There's so much that you can see just by using your own eyes. And later on, as it gets dark, you're gonna, and especially those of you that live out in rural areas like Wyoming, it's really easy to get out, and there's so much that you can see just with your eyes. And then people say, well, I can't afford a telescope. I really don't know anything about telescopes. Well, the very best telescope that you could ever buy are one of these. This is probably the best investment in a telescope that you could possibly do. So, binoculars. They're not very expensive, they're easy to carry around. At a star party, you kind of need to lower the expectations. People are not going to see the pictures like what you see in the magazines, like what you see on the websites. They're not going to look like that. Most of the things that we're going to look at, especially the deep sky objects, just look like gray fuzzy blobs. But one of the things that you do is that you allow your eye long enough to look at it, and the longer you look, the more details get brought out. People come up, they take a brief glance, they say, so what? It's a gray thing. Well, the longer you look, you kind of allow your brain to build up the information, and pretty soon you're able to start to pick out details. And one of the things that you can kind of do with people as they come up and look is you start to talk to them about what they're going to see, and you say, well, you know, sometimes people can't see a certain feature. When you know darn good and well that most people eventually do, but you kind of lower the expectations, and then when they do see this particular feature, then it's kind of there's this wow effect, and they feel like they've had a triumph. If you're looking at Jupiter with a scope that, you know, sometimes you can't always see the bands really well, or if you're looking at Saturn, you can't see the bands in the planet really well, and you say, well, not everyone can see the bands. Not everyone can see the gaps in the rings. And then when they do see it, they feel a little bit more triumphant and really awestruck, I guess. So a lot of times, lowering the expectations, they're not going to see, you're not going to see what you see in the pictures through this. But what is really cool is that you're really seeing these things. You're not seeing a picture, you're seeing them. And for many people, that's just an awesome experience. There was a guy at a star party that we did down at Ames a couple of months ago, and there was a guy that looked through my telescope, and he looked at Jupiter for the first time, and he's looking there saying, I'm having a religious experience. And it's just really neat. I think that's why we all go out and share our telescopes with people is because we give people the opportunity to see something that they've never seen before. And it really can have an effect on the kids, it can have an effect on the parents. A lot of your parents, a lot of your kids have never had a chance to look at these things, and so we really would urge everyone to find an opportunity to share the sky with your community of learners.
See that star right there I'm pointing to? That is Deneb. That is one of the intrinsically brighter stars in the sky. That is a blue supergiant. And it is going to die in a much, much more violent way than what we're looking at. That will go supernova. And when it does, it's going to be one heck of a show. It would show up in broad daylight. Wow. Heaviest stars, like Deneb there, will get to a point where they will have a core of iron. That's a problem, because in terms of thermonuclear fusion, iron is a dead end. When you attempt to fuse iron, you do not gain energy, you lose energy. So when this star makes this fatal mistake of trying to fuse iron, all of a sudden there's this energy vacuum. The star, that outward pressure that it had been depending on, goes away, gravity takes over, the star collapses very, very quickly. That sudden inbound collapse causes a massive, massive increase in temperature, a huge spike in temperature, and the star is disrupted, blows up. In both of these cases, the violent death versus the rather calm death we're looking at here. Hi, if you've just come up, we're looking at a dying star. Come on up the ladder. Take a look in the eyepiece there. Please hold on to the ladder, don't grab the telescope. And you'll see something that looks like a bubble floating out in space. That's the outer layers of a dying star being blown up. Okay, so has everybody had a chance to see the dying star?
No, I'd like to if I could.
Well, come on over and take a peek.
Hopefully I can wave at you in a star party someday.
This is a great way to get people introduced to astronomy and having a good time and working together and learning about the sky.
I am looking at Jupiter and its moons, a couple of its moons, and I think I see, yeah, and I see some rings. Do I see rings?
Yes, those are bands of clouds.
Okay.
As it spins around.
And what's the name of the moon that's the closest on the left-hand side?
It's hard to tell because it could be that their orbit has just brought it real close to the planet, and it's sometimes hard to see if it's a.
It's awesome. It's just, it's very exciting. It's very exciting.
Sorry, I got caught on the satellite.
Did you find the satellite?
Oh, got him. I got him.
Okay.
Over just to the left, right?
Now, if you look at those through a telescope, each of those two stars becomes a double star. So it's called the double-double. And I don't think that, even though those appear to be a double star, they're separated, of course, in space. One's way further than the other.
Yes.
But the two doubles of the double star, I think of those two, one of them actually is a true double star.
One part you probably have was
I keep looking at the satellite. That is so neat.
Oh, it was wonderful. You could see, we looked at Jupiter, and at first I could see 3 moons, and then I came to another telescope and I could see 4 moons, and I didn't even know they were there before. So it was great.
I am experiencing some of the most phenomenal things that we learned about today, and all right here that I can see with my own eyes. And I think it's, I really like Jupiter and the moons. That to me was the most fascinating. But I'm very excited for the near approaching International Space Station. And I'm hoping to really I get to see it quite often, but I think I'm going to enjoy it more with being among these wonderful people.
A nice view of the ISS flying over. Well, we're gathered here to watch the International Space Station make a pass tonight, and it's due in just about a minute or so.
So we should be looking west?
Yeah, it's going to come out of the west-southwest. It's going to go up. It's going to climb into the sky. When it gets into the northwest, it'll reach its highest, which will be about 36 degrees up. And then it's going to disappear into the northeast. So everybody kind of look over this direction. It'll take a few minutes.
How long will it pass?
A couple minutes.
It's phenomenal. Absolutely phenomenal. To watch the space station go over the
You guys
top
gonna watch
with
that
NASA, with my friends. Spectacular.
Awesome.
It's been a spectacular conference.
Everybody got across their fingers.
And it's really neat that it's going across Cassiopeia right now. That's a constellation. Very excited to be here.
Are you going to be there with them?
No.
That's cool. I'm going to have to touch the scope back here.
Oh, wow. Billions and billions.
Right about there.
Wow.
Wow.
Oh, my. That was just beautiful.
Isn't that a gorgeous object?
Oh, incredible.
Don't worry, it's going to get better.
Okay.
That's amazing.
Let's see what you have.
Incredible. Now, when these are the telescopes outside, if we look at that.
About there. Yeah, this is actually an object that you can see in a fairly small telescope.
Okay.
Of course, the bigger the telescope, actually the better it looks.
Holy crap.
Holy crap, that's a good reaction.
Did I say that?
I'll take that. I'll take that. That beats why the hell did I come up here?
I think it's pretty cool. I think I might actually try to get the telescope out of the box.